Hi everyone, welcome to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. And this channel is intended to those who are doing the online classes out there. Hello. And those who are also answering their modules. This will help you build your concept about your lesson in mathematics. So please do not forget to share this video discussion to your friends out there. At least you will help them realize that math is not a difficult subject, but it's easy, fun, and interesting. So now let's proceed to our video discussion for today. We will be talking about data management as part of our discussion last time in statistics. So for a while, I'll share the screen. As you can see, data management, when we say data management, this is something to do with gathering and organizing the data. So now there are four levels under data management that we need to understand, especially the four levels of measurement of data. So under the data, we have the qualitative data. We also have quantitative data. So as you can see there, qualitative data scale can be categorical or can be grouped, while quantitative data or scale can be numerical. So I'll highlight this one so that you can follow. Quantitative, as I have said, it's numerical. It can be measured. So under the qualitative or categorical, which can be grouped, we have the nominal and we also have the ordinal. When we say nominal, this cannot be arranged in any particular order. Best measure of central tendency is the mode, and then the best measure of spread in here under nominal it's not. Okay. For the ordinal, it can be arranged in order. The best measure of central tendency in our under the ordinal, we have the median and mode. And of course, for the best measure of spread under ordinal, we have the IQR, familiar, the interquartile range. Under the quantitative or numerical data scale, as I have said, it can be measured. So we have the interval and the ratio. For the interval, we have 0 is arbitrary. So the best measure of central tendency, we have here the mean, median, and mode under interval. And of course, for the best measure of spread or range, what I mean, the best measure of spread under interval, we have the range, variance, standard deviation, and IQR or the interquartile range. And of course, for the ratio, 0 is not arbitrary. So, and that means none, and means none rather. So again, under ratio, 0 is not arbitrary and means none. So 0 is not recognized under the ratio. So the best measure of central tendency in here, we still have the mean, median, and mode since it's under quantitative data. And the best measure of spread, we have the range, variance, ST, and IQR. The only thing that differs in here between the interval and ratio, interval 0 is being defined or can be recognized or is arbitrary, while 0 is not arbitrary and means none in or under ratio scale. So I hope you can follow with this basic concept that I am sharing right now in this video discussion. Now let's try to discuss about the types of data on the basis of measurement. In here, we will go over or explore the concepts that we just learned, the types of data that we have. We have the nominal, ordinal, interval, and ratio. So when we talk about the true zero, I highlight true zero, nominal, no. For ordinal, we have no. 0 is being defined. This is what we meant. For interval, we have no. 0 through 0 is not being not defined in here. But in ratio, it is defined. Yes. For the equal intervals, for nominal, no. For ordinal, no. For interval, yes. And for ratio, yes. And for the order, of course, only the nominal does not need to be ordered. So it's no. Ordinal, yes, it must be. Yes. For interval, it must be also. Yes. Ratio, of course, it needs to be in order. So for the category, as you can see, nominal, it's very known to be categorical. So it's yes. For ordinal, yes, it could be also. It can be yes. For interval, yes. And for the ratio, yes. And for the examples, if we talk about the examples, if we try to cite rather an example for the scales that we have here, for nominal, we can have the marital status, the sex, the gender, the ethnicity. And for the ordinal, we have the student letter grade, the NFL team rankings, and for the interval, temperature in Fahrenheit, SAT scores, IQ, and year. And for the ratio, we have the examples in here, the age, height, and weight. So I hope you can follow about the discussion of the types of data based on the measurement that we have. So now, moreover, we will now proceed to the next slide, which talks about the measures of positions. For the measures of positions, we have the percentiles, quartiles, and deciles. These are the three terms that I mentioned. These are part or measures of position. So please don't forget for the measures of positions, we have again the percentiles, the quartiles, and lastly, the deciles. So let's talk about first percentiles. So as I mentioned before, if I know, I don't know if I just meant if I mentioned this one. So when we say percentiles, percentile is the value. Say with me, value. It is the value below which a percentage of data falls, and that refers to percentile. Let's have an example. Let's say you are the fourth tallest person in a group of 20. So there are, as you can see in the illustration, there are 80% of people that are shorter than you, of course, based on the illustration. So this is you. And as I have said, there could be possibly 80% of people that are shorter than you. That means you are at the 80th percentile. So if your height is 1.85 meters, then 1.85 meters is the 80th percentile height in that group. And that's how we illustrate a percentile. So in order, have the data in order so you know which values are above and below. Okay, so to calculate percentiles of height, have the data in height in order or sorted it by height. Then calculate percentiles of age. To calculate it, have the data in age order, and so on. So in short, in identifying your percentiles, it's better for us to really order our data. It could be from highest to lowest. Okay, don't forget, percentile means the value below which a percentage of data falls. So based on the example that I said or that I presented, if 80% of people are shorter than you, then that means that you are the 80th percentile. Okay? So now let's have another examples in solving percentiles. So in percentiles for grouped data, when the data is grouped, add up all percentages below the score plus half the percentage at the score. So please do not forget this one. This is a process in finding the percentiles when the data is grouped. So let's say, or let's have an example. You score a B. In the test of 12%, what I mean, in the test, 12% got D, 50% got C, 30% got B, and 8% got A. So you got a B, so add up all the 12% that got C, as you can see in the illustration. So we have it 12% for D, 50% for C, 30% for B, and 8% for A. So 50% that got C, as you can see there, half of the 30% that got half of the 30% that got B. So half of it. So this is the percentile rank for B. Since our situation is your score, or you score a B. So meaning to say from D to half of B is the percentile rank for B. So meaning to say for the percentile of 12% plus 50% plus 15%, the half of B, that gives you 77%. In other words, class, you did as well or better than 77% of the class. So why take half of B? Because you should not imagine you got the best B or the worst B, just an average B. So you are the average, you are the basis. Okay? So the percentile rank for B is 77% from D to the half of B. So I hope you can follow. This is for the percentiles. Now let's proceed to the next measures of position, which is known as deciles. When we say deciles, these are similar to, or deciles are similar to percentiles. It sounds like decimal and percentile together. So as they split the data into 10 groups. So in short, deciles divide the data, our given set of data, into 10 equal parts. So in short, the first decile is also known as the 10th percentile. So in short, the value that divides the data, so 10% is below it. So that is the meaning of that. The next is the second decile, or another example, the second decile is the 20th percentile. So the value that divides the data, so 20% is below it, and etc. So as you can see in the illustration as projected on the screen, you have it there, how I illustrate the 8th decile. 8th decile is the 80th percentile or 80%. So we borrowed the example a while ago. So this is you. Of course, below you is the 80%. Okay, lower than your score. So you are the average, you are the basis, in short. Okay, so deciles again, deciles is dividing the data into 10 equal parts. So it's by 10. So now let's proceed to the next slide. The quartiles. Quartiles is the last measures of positions. So another related idea, as I have said a while ago, quartiles, this splits the data into quarters or into 4 equal parts. So let's have an example. Sorry, let's have an example. The example that we have it there, as you can see on the screen, we have 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So the numbers are in order. So we cut the list into quarters. So this is your Q1. Of course, the first thing that we're going to do for quartiles, find the Q2 or the median. So the Q2 is in here. So below the Q2, that's where you can find your Q1. So find the median below your Q2. So it's obviously 3. That is already your Q1 below your Q2. And higher than your Q2, you find it there for your Q3. Then find the median of the data. So 7 is the median of higher than the Q2. So this is considered, or this is already your Q3 or the upper quartile. So in this case, quartile 2 is halfway between 5 and 6. So your Q2, of course, you just add 5 plus 6 divided by 2 to get its average. Then 5.5 is your Q2. Same process in getting the median. For Q1, we have it 3, as I mentioned. Quartile 2, we have 5.5. And quartile 3, or upper quartile, is equal to 7. So now, the quartiles also divided the data into divisions of 25%. So in short, Q1 is 25% of the given set of data. Q2 is the 50% of the given set of data. Q3 is the 75% of the given set of data. In short, quartile 1 can be known as 25th percentile. Quartile 2 can be known as 50th percentile. And quartile 3 can be known as 75th percentile. So I hope you can follow. Okay, so that is just a very easy concept for you, I guess. So let's have an example. 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So now what is the 25th percentile? So if you are very wise to answer this question or problem, count how many numbers of data do we have? 2, 4, 6, 8, 10. So 10. So meaning to say 5 and 6, you can find it here. So 5.5 is your median or Q2. Again, Q2 or the second quartile is considered as your median or the 15th 50th percentile. So 5.5, that's correct. And from here down here, this is your lower quartile. Find its median, 3. So this is the 25th percentile. And of course, upper than the Q2, get its median. 7 is the median, so 7 is the 75th percentile. So I hope you can follow. So now let's talk about z-scores. I know you're familiar with the z-scores. Remember the z-test? Okay, so this is something related to it. So a z-score is a numerical measurement that describes a value or values relationship to the mean of a group of values. Okay, relationship of a value to the mean of a group of values. So please do not forget that concept. Okay, so z-score is measured in terms of standard deviation and from the mean. So again, measured in terms of standard deviation, we use the standard deviation from the mean and also the mean. We need it to solve your z-score. And if a z-score is 0, take down note, it indicates that the data point score is identical to the mean score. So that's the meaning when the z-score is 0. Now, this is the formula to find your z-score. So your z is your z-score, of course. Your x here, that is your score. Your mu is your mean. Please take down note of that. This one, the sigma, is your standard deviation. So I hope you will be able to recognize the symbols, because if you cannot recognize it, then it will be difficult for you to solve or use the formula in solving the z-score. So now let's have an example so that we can appreciate the formula. So example, we have a given score x 95 for your mean 100, and of course your standard deviation 10. So you will just substitute it to the formula that we have. So 95 minus 100, that gives you negative 5. 10, just copy the 10. Then if you're going to divide it, that gives you negative 0.5. So as you can see, your z-score is negative. What is the interpretation? The interpretation here is a score of 95 is 1/2. Say with me, 1/2. Okay, so of the standard deviation below the mean. Again, the interpretation for that is a score of 95 is 1/2 of a standard deviation below the mean. So I hope you can follow. So now let's have another example so that you will be able to master this one. Let's say John got 76 marks in his statistics test. If the marks of the whole class had a mean of 52 and a standard deviation of 8, what was John's standard score? Remember the formula? So identify first your score. Your score is 76. That's very obvious. So your x is 76. And then find your mean. Your mean is, of course, 52. Very, it is mentioned in the given. And of course, your standard deviation based on the given is 8. Very easy. Excuse me. So you can now just substitute it here in the formula. Then you can have it and then divide it and simplify it, and that gives you, or it will give you 3. So I hope you can follow. Now let's proceed to another example. Given the mean of 55 and standard deviation of 8, what score corresponds to 2 standard deviation above the mean? So in this case, you are given like, yeah, given the z, given the mean, given the standard deviation, then you are looking for your x, as you can see. So your mean is 55, so we substitute it based on the formula. Standard deviation is 8, so we have it 8. What score corresponds to 2 standard deviation above the mean? So meaning to say 2, the z-score is 2. Sorry. So we are looking for the score. So the score is missing, the x. So now we will just substitute and then simplify. 8 times 2, that gives you 16, is equal to x minus 5. Then transpose it there. That gives you 16 plus 55. And then when you add it, that gives you 71. Very easy, right? So easy to find your z-score. Now let's proceed to the next. This one, something like challenging. Given the following data, in which subject did Rowell perform poor? So it's very hard to identify. So you need to get your z-score in order for you to identify which subject did well perform poor. So the given it's there. You have the score here, Rowell score. Then for math, we have 90, mean is 85, and 1.5 for standard deviation. So the answer for the math is 3.33. This is the z-score. For the z-score of English, you have it here, 95, 97 for the mean, and standard deviation, which is 2. That gives you negative 1. This is the grade of, or the z-score of Rowell in English. And for MAPE, you will just follow the same process. Then you have it 1.14. So as you can see, which one has the least? The question is, which subject did Rowell perform poor? So therefore, what I mean therefore, Rowell performed poor in English since the z-score of English is negative 1. So this is the subject that Rowell performs poor because English has the small value of the z-score. So that's how you identify it. So I hope you can follow. Okay. So now let's proceed to the probabilities and normal distribution. So standard normal distribution, this is a distribution of a normal random variable with mean 0 and standard deviation equal to 1. So since standard normal distribution is something related to probabilities, meaning to say the distribution is between 0 or the mean 0 and standard deviation to 1. A normal distribution is sometimes, not sometimes, most of the time it is very known to, it's called the bell curve. So it's a distribution that occurs naturally, so normally in many situations. The Gaussian distribution is another name for normal distribution. Do not forget, Gaussian distribution is also known as normal distribution. So in statistics class, the normal distribution is called the normal curve. So if you encounter a normal curve, that means that your distribution of the data is normal, okay? So in the social sciences, it is called the bell curve. So bell curve is the term for normal distribution or a normal curve in social science because of its shape. That's why we call it bell-shaped or bell curve. In physics, it's called the Gaussian distribution. So it's very important for us to know that different terms used for the normal curve or normal distribution. So properties, the very most important thing in here to build the concept of normal distribution. Under the normal distribution, these are the properties that must be satisfied in order to consider the data as a normal distribution. First, the mean, mode, and median must be equal. That's why it's symmetrical. Okay, it's symmetrical because the mean, median, and mode are equal. So this is the first consideration or properties that we need to remember for a normal distribution or normal curve or bell curve, bell-shaped curve rather. So the another property is the curve is symmetric at the center. So I already have drawn it here, right? Sorry for my penmanship. I can't really write it correctly and equally. So again, the curve is symmetric at the center. And then exactly half of the values are to the left. So we have it to the left in here, direction, and to the right. From the center to the left, and exactly half the values are to the right. So the total area under the curve is 1. So please take down note. 1 is the total area under the normal curve. So the normal distribution. So I hope you can follow. Now let's proceed to the next. So normal curve is a symmetrical bell-shaped curve, as I mentioned a while ago. The end tails are continuous and asymptotic. What do you mean by asymptotic? It will just cross on the line. It will just be almost cross the line, but it never touches it. As you can see, I'll highlight this one. This is the one that I am trying to imply. See, this is asymptotic. It's end tail of it. See? It never touches the line or the horizontal line, but it's just getting closer and closer. So meaning to say, when we say the normal curve, that means the mean, median, and mode are equal. We don't have an issue about that one, okay? And when you add their probabilities, the answers is always 1. Then the scores are normally distributed if the computed value of SK or skewness is equal to 0. So I want you to remember this one. This is an example of a bell-shaped graph, which is under a normal distribution. distribution. Okay, so now let's proceed to the linear regression and correlation because we have a lot of things to talk about it in here about this topic. So correlation refers to the statistic. When we say correlation, and according to Diane Kiernan, 2014, it refers to the statistical association between two variables. So a correlation exists between two variables when one of them is related to the other in some way. So a scatter plot, I'll highlight this one. A scatter plot is the best place to start. So a horizontal axis and a vertical y-axis, these are scatter plot, which is a graph of paired sample data with x-axis and y-axis. So each individual xy paired is plotted as a single point. So you are just plotting points in here. So scatter plot can identify several different types of relationship between two variables. So a relationship has no correlation when the points on scatter plot do not show any direction or pattern. So a relationship is nonlinear when the points, I want you to highlight this one, no correlation, nonlinear, when the points on a scatter plot follow a pattern but not a straight line. Again, when a scatter plot is not a straight line, then it is a nonlinear. And if the scatter plot do not show any direction, then there is no correlation. So take down note of that, please. And a relationship is linear when the points on the scatter plot follow a somewhat straight line pattern. This is the, I will show you later about the illustration of these rather. So this is the relationship that we will examine for the linear. And for the linear relationships can be either positive or negative. So it could be, it has a positive relationship or a negative relationship. So it depends upon the situation or the given set of data that you have under correlation. So as x values decreases, y values decreases. As x values increases, y values increases. So this is the relationship between your x and your y under correlation. This one I'll highlight. For example, when studying plants, height typically increases as diameter increases. So that is the relationship or how we illustrate the relationship of your x and y under correlation. So now, as I have said, it's very difficult to imagine without knowing its graph. So later I will present to you the graph. So in this case, first, let's define first what is a correlation coefficient. Correlation coefficients can be known as R, are computed, and the most widely used measure of correlation is the Pearson product moment correlation coefficient, or simply called Pearson R. Pearson R is the most common statistical tool used to measure, or that is used to measure a correlation. Okay, do not forget that one. So this is the formula for your correlation or correlation coefficient using your Pearson R. The R will determine the relationship of your x and y, if there is a relationship or none, or if there is a positive or negative relationship. So the formula for x, y, so let's just define the what is in the formula or symbols used in the formula. X there, x in here is the observed data for the independent variable, and y is for the dependent variable. So most of the time in correlation, you are given the x, the value of your x and y. And then your n is the sample size. How many number of data do you have? Summation of x, meaning to say you will add all the values of your x. And summation of y, you are just going to add all the values of your y. And for summation of x squared, you will just add or get the total of all the square of each values of your x. And for your summation of y squared, that gives you the summation of the square of each y values. And of course, summation of xy is the sum or total of the product of your both x and y. So I hope you can follow with the descriptions that we have so that you'll be able to know how to use the formula in solving for the correlation. So this is the table used to describe the result of your R or your correlation coefficient. Again, the R will determine the relationship of your X and Y. So if the, let's say based on the table, if the range of correlation coefficient is from 0.80 to 1.00. Remember 1.00? Very strong, or the interpretation of that is there is a very strong positive relationship between your x and y. But if you have this one, negative 0.8 to negative 1.00, that implication of that in research is, or under correlation is, it has a very strong negative relationship. So I hope you'll be able to take the note of this, because the table is very helpful, okay, to interpret the result of your R, or your correlation coefficient. What do you call the R, in the Pearson R? That is the correlation coefficients. Okay, now let's proceed. So this is an example of the graph that I mentioned a while ago. So if this is the graph, or the scattered plot rather, the look or its illustration, that means there is a strong positive relationship. If the scatter plot is like this, then it has a strong negative relationship. And if it's like this, then it has a weak positive relationship. If the plot is like this, then it has a moderate negative relationship. And if the scatter plot is like this, it doesn't form any line anymore perhaps. So then we can just say that there is no relationship. And if this is like, or more scattered, but it's like it will form a line, then if the graph is like this, then we have a weak negative relationship. So I hope you can follow and can identify how to solve, how to get your R, because in the next video, or in the next in the next slide, we will compute the we will compute the or we will have an example to use the formula so that we can compute your R. So let's have an example. A study was conducted to investigate the relationship existing between the grade in statistics and the grade in computer subject. A random sample of 10 computer students in a certain college were taken, and the data are as follows. So as you can see, we have the data there. So your problem now is there a relationship between the performance of the students in statistics and the computer subjects? Let's see. First thing that we're going to do, this is my part of my clue to answer or to do this one. Of course, you have to memorize the formula. After you memorize the formula, of course, you have to provide a table. So you are given right away 3 columns for these are given already. So all you have to do is just to fill in your xy, your x squared y, and of course your y squared. So how to do it? Of course, for your xy, you will just multiply 75 times 78. That gives you 5,850, so on and so forth. To get your x squared, of course, you just square this one, all the values of your x. Example, 75 squared, that gives you 5,625, and that is your x squared. To find your y squared, you will just square your 78. That's how you will get it. And after that, count how many data do we have. There are 10 of them from A to J, so n is equal to 10. For your x, summation of x's, you will just add them all. This one, these, add them all. So that gives you 837. And same thing in here, summation of y, you just add them all. That gives you 845. And for xy, you add it, that gives you 71,030. And for the summation of x squared, that gives you 17,413. And summation of y squared will give you a sum of uh, 7,100, 71,717, sorry, this one. Okay, so next step that we are going to do is we will now remember the formula. We already have the formula on the screen. So we will just right away substitute or identify the given. So where did we get it? N is 10, as you can see. And then summation of x, y, this one. That's why we have it here. For your summation of x, 837. So you have it there. So 845 is your summation of y, this one. So 845. So same process in here. We'll just follow the rule. So n is 10. This one, summation of x squared is this one, 70,413 minus This one, 837 summation of x squared. So summation of x squared is 70,430. Okay? Sorry. What I mean, this one, summation of x is 837, then square, based on the formula. I'm still here, sorry. And then n is 10. We are here. And the summation of y squared is 71,717. And minus, of course, the last part is the summation of y, which is 845, then square it. Then you have it 3,035 over square root of 3,561 times 3,145. So you multiply the denominator and get its square root. Then what will be the result? 3035 will be divided by from the result or based on the result. So our answer is 0.91. This is your R. So what is the implication of that? Let's see the implication. Therefore, there exists a very positive relationship between the performance of the students in statistics and computer. Why very positive? Because it's closer to, look at, try to observe. 0.91 is your R, and that is closer to 1. Remember the one that I told you a while ago, this one? Okay, 0.90, that was 0.90, right? See, 0.90 is located in here, so that's very strong positive relate, or it has a very strong positive relationship. So I hope you can follow. Now let's proceed to the linear regression. So in linear regression, a simple linear regression model is a mathematical equation that allows you to predict a response for a given predictor value. So this is used in the process of basis of the knowledge of the predictor, or we call it the X. One example is the prediction of job performance of an applicant using information available during the time of his application. So when we say linear regression again, it can be computed using the equation y is equal to a plus bx, which is called the least square line or the simple regression. So to define it, your a here is your y-intercept, your b is your slope, as being defined and described, sorry for the inconvenience, and for your x is the predictor variable, and your y is the estimate of the mean value of the response variable for any value of the predictor variable. So I hope you'll be able to grasp the concept or the description of each symbols that I presented in here. So again, your A is the y-intercept, your B is the slope, your X is the predictor variable, your Y is the estimate of the mean value of the response variable for any value of the predictor variable. So to solve for your y-intercept, or the y-intercept rather, is the predicted value. This is the value that we are trying to predict, the y-intercept, the y. So this is based on the description that you can see there in the formula. So the y-intercept is the predicted value for the response or y when x is equal to 0. So the slope describes the change in y for each 1 unit change in x. So now the values of a and b can be obtained using the formula that is presented there on the screen, this one. And of course, this is how you get your b, and your a is or can be used using this formula. We described this one a while ago in the correlation formula. So where your m here sub ny, that means the mean of the y values. Your m, I'll just write it, nx sub nx, that is your mean of the x values. So I hope you can follow. So next, let's proceed to the next screen or next slide. Okay, in the next slide, we are going to compute. What I mean is we're going to use the formula that I just mentioned a while ago so that you can appreciate the importance of it. So here is the example. So given the following data on correlation between the grade in statistics and computer, what would be the predicted grade of a student in computer who has grade of 85 in statistics? and what regression equation could be used. So you have there the table. So the first thing that you're going to do, identify your x and identify your y, so that you will not be confused. So your statistics can be your X and your computer, it can be your Y. So now let's have it. So make a table. So please do not forget to make a table in solving a linear regression, or when you do regressional analysis, because that will help you remember about what to solve and which value is needed to solve. So now you have your X is your statistics grade, so you just copied from 75 to 84. So from 75 to 84. And for the Y, you have it your computer. So from 78, as you can see there, down to 84. Okay? So now you provide your XY. You just multiply 75 times 78. Same process as how we do it how we do it in solving the correlation. Okay, so that's 75 times 78, that gives you 5,850, until 8 times 84, that gives you 7,056. So that's how you do it when you get the product of your x and y. And for the x squared, of course, simply you will just get the square of your x. Your x is 75, so the square of 75 is 5,625, until 84 squared, which gives you 7,056. And of course, you will do the same thing in y squared. For y squared, you will just, same process, 78 squared is 6,084, until 84 squared, which is 7,056. So that's how you get it. So always remember the table. How many columns do you have to add? Three columns. Very good, because you have how many columns all in all? There are six columns. Very good. So now your n, you will just count how many are they. There are 10 of them. Of course, you will just add your x. Summation of x is 837, and summation of y is 845. Summation of xy is 71,030, and the summation of x squared is 70,413, and the summation of y squared is 71,717. So now we will follow the formula that we just that I've shown a while ago. So you have it there. You will just substitute it to solve for your B. Remember the formula? So I hope you will be able to remember, and you take the notes of the formula so that you will be able to remember it. So you have it 3,035 divided by 3,561, and that gives you your value of your B, which is 0.85. Now our problem is to get your A. So this is how to get your A, as you can see there. So use the formula. So after using the formula, then you have it, sorry, and then you have it m sub your m sub nx. That means you are going to get the mean for your x. So the mean for your x is 837 divided by 10. That gives you 83.7. And for your m sub n y, that is your summation of y, the average of your y, which gives you 84.5. So 845, as you can see there, divided by 10, that gives you 84.5. And of course, to get your A, you'll be needing the mean of the X and the mean of your Y. So you have it 84.5. Where did we get 84.5? Based on the formula that we just that I introduced a while ago. So you have it 84.5, which is your M sub NY minus 0.850, which is um, multiplied it by 83.7. Where did we get 0.850 from your B? Okay, so multiply it again. I advise everybody to please take note and memorize the formula so that you will be able to compute the value of your A, and to follow the process of of solving or finding the linear regression, solving the linear regression of a given set of data. So you have it 13.36, which is your A now. So now the regression equation, remember, y is equal to a plus bx. So your A is 13.36 as we just solved a while ago. And then your B is 0.85. Multiply it by X. So this is already your equation. This is already your linear regression equation. So now, if the grade of a student, so if the grade of a student in statistics or your X is 85, then if you're going to predict the computer grade, as I mentioned a while ago, linear regression is another statistical tools that can help us predict a certain circumstance or situation. So if the grade of the student in statistics is 85 or your X is 85, then to predict the computer grade of your student, we have it following the equation, and then 85 is the grade, your X, so just replace X by 85, and then to solve it, that gives you 85.61 or 86. So the grade, if the grade of the students in statistics is 85, then the computer grade of the student will be 86. So that's the use of the linear regression model. So I hope you can follow, and please not forget to memorize the formula and take down notes of the formula so that you will be guided on what tables or columns that you have to or need to add. Okay, so we will end here. So that's it. So that's about data management. So I hope you'll be able to grasp the concept and the process and steps on how you solve some statistical tools that we just mentioned in this video discussion. So now, thank you for listening. I hope you do not forget to subscribe my channel. So please do not forget that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. So always remember, again, that math is fun. Have a good day. Thank you and